Hi everyone. So in today's video or stream, we are going to be continue with our Odin programming series, and what we'll do in this one is we are going to explore this cool concept known as fractal tree or fractal canopy. And the main idea here is to generate this tree sort of a structure. If I open this one, so this tree like structure, and the way it is generated is quite interesting. So you can write very less amount of code and generate this particular tree, which is known as fractal tree. If you look at this particular tree, I should probably set up my drawing pad. So just give me a minute. Okay, so I have my drawing pad set up, and now I can draw some things. Okay, so for drawing, let's use this app, right? So the way this tree is created is very interesting, and why I say it is interesting is because see, so this is known as a branch. If I go back to this, how do I remove this one? This is a branch. So this is a branch of a tree, and then we generate other branches of this particular tree. And the way you generate other branches is you use same branch and you angle it off like this, and you angle it off something like this. Okay, uh something like this. Now from this point you have drawn these two branches at like certain angle. So if I draw uh x-axis and y-axis, so this is the angle which will say theta, right? So this is the angle, basically this one, this is the angle theta. So you generate in the left direction and in the right direction. Then what you do, you take this one as a point, for example, and you generate one more on the left, one more on the right. And one more thing you will notice is the length. So the length of this branch keeps on decreasing. So length initially might be 10, then it becomes 9, then it becomes 8. That's up to you how much reduction of the length that you want to do. uh I hope you're not facing any issues, because it say the stream health, it says. Okay, we'll take care of this, right? uh what happens here is you generate this one, then you come here, you angle it off here, and you angle it off here. This is how you generate like this particular tree like structures. So you can see we have this branch, and then we have other branches emerging out from it, and that's how you draw a fractal tree. And the interesting thing is you can write a recursive function. So basically you have to draw a branch, you have to angle off, you have to draw branch, you have to draw this branch, then it is a recursive function. You come here, you draw another branch, you draw another branch, and so on. So this is classic recursive piece of code, right? So this is what we are going to do today. We are going to draw it in Odin. Basically you can use any programming language that you want. In terms of library, I will be using the Raylib library. So if I go back here, so Raylib is a pretty cool library. It's simple to use uh, library for drawing stuff. You can use something like SDL2, SDL3, that is also fine. Maybe your language has some other libraries. So there are a lot of bindings, as you can see. It supports a lot of platforms, it supports a lot of language bindings, and we have C Sharp, we have Golang, we have Lua. I think this is Lua. Yeah. Python, Rust, Zig, and we have Odin as well. So I'll start with the Odin. Okay. So the cool thing about Odin here is it has the Raylib library baked in the standard library, so you don't have to pull in anything else and then install any other library via package manager or something like that. So this is the, you can see this is the Odin project that we have here, right? And the way we use this library is something like this. So we have an example. Let's do one thing, just copy this example and start with our adventure. So I'll call it Fractal uh, tree Odin. So Fractal tree Odin. We create a main.odin file. I'll just paste this example and change a few things. So Fractal tree Odin. This is your what you call it, the title. So if you see, there is like a title here, main.odin. This is your title, and this is your height and your width, I believe. One cool thing is you can go to this Odin file, raylib.odin, and you can look at like all of the functions that this library basically provide. So something like it provides like a lot of colors. There is white, magenta, blank, black, and all of those stuff. The cool thing is this sort of acts like a documentation for this library, and you can do cool things from this. So what I want to see is for this method that we have, init window, I want to see what is these parameters. So this is width and height. I don't know the order. So init window, so it is width and then height. So I'll just do one thing. I'll make them constants. This is my width and my height is going to be 450. And then I can come here and use those constant. Okay. Now what I want to do is I want to go into that folder, do Odin run dot. Yeah, so we got a window that says congrats, you created your first window, which is pretty cool. So we have this one over here. We have some weird formatting, I don't know why. So we begin drawing, we end the drawing. So the library is pretty intuitive to use. You initialize a window. There is a loop, drawing loop, game loop, whatever you can call it. So you have a draw loop which will draw stuff after certain period of time, and how it is decided when it will draw is you set the target fps. So I'll set the target fps to 30. We don't need even 30 in this case. Yeah, so nothing will change after doing that. And this is the draw loop which checks for window should close. So while the window should not close, you basically draw things on the canvas. So I'll say rl dot black. Do we have black? Yeah, we do have black. And okay, I don't want to draw any text. I just want a blank window. Right. So we have the window now. Now, what I basically want to do is I want to basically start with, okay, do I have access to my drawing board? Is something disconnected? So I use this drawing board. I think it doesn't have battery, so it's out of battery. But good thing is that we drew this particular diagram. So I want to draw this branch first. This is simply a line with some sort of a thickness. That is how you can think about it, right? And how we can draw a line. So let's see. We see there is a draw line function over here where you can provide the start position, start and end positions, and the color itself. One more thing that you can do is you have a draw line ex. So I'm not sure what ex means, but it provides you this thickness parameter as well. So you can create a vector 2, and from that vector 2, then you can do stuff. You define a start position, end position, the thickness, the color, and so on. So what do we do over here? Let's come back to our code. Let's start with drawing like a simple line. I will call it like uh, draw branch. So it is a proc that doesn't return anything. What it takes is the start x, or we can pass a vector, vector 2. So start and will be type vector 2, and then we will have our uh, thickness. Since the thickness is also changing, if you notice it here, the thickness here is more, then it starts becoming less and less, right? It looks pretty cool when you zoom in, but anyways, uh, right, so back to our code. We want a thickness which will be float, and let's see what the thickness is being passed here. So drawline ex, the thickness is f32, which is correct, and we have some other things that we want to pass maybe, and we will see as we go ahead. So what I'll do here is, after clearing the background and setting it to black color, I will call draw branch. Also, one more thing is we need an angle. So the angle initially, I think uh, it should be, so the angle is basically this one. I think I drew it incorrect. And do we open a new page in here? I don't think so. Okay, so the angle is, I think, perpendicular to this. So if we have this branch, this is basically I think 90 degrees, I think, because if you draw something like this, this particular angle over here is 90 degrees, I guess. Right, so we will start with an angle of 90. So start vector we need to define. Start vector is start position. So I'm not sure in Odin if you define variables by underscore or what is the convention. So this is variable declaration. Okay, it is snake case, I believe. Right, so we are going to use snake case starting position, which is vector 2. So how you can define a vector 2, I believe, is something like this, vector 2, and then you can define the vector 2 with your x and your y. So x will basically be, if you take the x-axis, uh, x is in the middle, so at the center. So center will be something like width divided by 2, and the height divided by 2, right? And what else we have? Width divided by 2, height divided by 2 will, okay, is not correct because it will center it, but in terms of the y-axis we want it to be touching the bottom part of the uh, canvas, so it should be height. So we have the start position, and the end position will be, let's say I want to define and something like this. We have a vector 2, and we will have the width. So width, it was half, it will remain half here as well, right? But the height will change now. So height was like, if this is our ground, so height was, so this is our canvas, for example. Height was y. So now if you subtract something from height, it will be here. So y minus, for example, y minus 10 would be here. So here if you want to draw something, right? So we will do y minus 10. Y minus 10 is basically height minus some number. I'll say 10 for now. And let's see, let's draw this thing and see how it comes out. We also want to pass in a angle which will be f32. So these both are f32. I can remove this one. And what else do we have over here? We have to pass the thickness. Thickness, I'll say like 4 pixel, and the angle will be 90. And one thing, the angle is in radians, I believe. So we do have a function to convert Raylib cheat sheet. Open this one. So there is a method to uh, degree to radian. There is a method, degrees to radian Raylib. Okay, and it says something, but yeah, I wanted to find out that function. I go in here and check. We have two. How many occurrences of two? We have a lot. I wouldn't be able to find it this way, I believe. Let's go to the top of this page, and it should be somewhere on the top, I think. And yeah, we have this. If you see here, degree to radian. So what we can simply do is we can multiply our angle that we have over here by RL dot degree to radian. Right, this is our angle. Now let's come back to our draw branch. What you want to do, simply first of all, here is you do RL dot draw line ex. You pass in the start, the end, the thickness. Right, so right now that we aren't using the angle, because I will come up with the angle stuff. One thing that I would like to have is my drawing pad back. So just a moment, check this thing. It doesn't work for some reason, which is unfortunate. Can I connect this long cable? Connect this. This, yeah. So I've connected it, and do we have anything? I'm not able to draw. I can do one more thing, but I believe it should be working. Can I have it connected properly? I believe. Yeah. Okay, what I'll do is I'll put it in some form of charger. Uh, I don't think it's even charging. No, it's not even charging. So I can use this iPad for drawing stuff. I believe we need to connect this thing. It says it's connected. And can we use it? Okay. QuickTime Player file, new movie recording. Okay, this just shows me stuff which I don't want. I'll try it again. It doesn't show my iPad for some reason. But yeah, I guess we have to deal with it without any drawing. It will be interesting explaining this stuff. So yeah, draw line EX. If we do this correctly, it should compile, but it didn't. And I believe we don't need this now. Vector2 is not a type. Do we have to do rl.vector2? Okay, it says over here rl dot and cannot assign values, draw branch of f32 to invalid type. It says we have vector2 over here, vector2. Let's see. Only one error we have, the color. Okay, we are not passing the color. So I'll say rl dot relib white. Relib white is not declared. There is a color called relib white, ray white. Okay. Now we run this and we got a line. It's a pretty small line, I should say, but we have a line nonetheless, right? And okay, so we got a line, which is good. But now what we want to do is we want to have the line of like some more height. And for that, what I'll do, I'll say 50 over here. Now we have a taller line, and I think instead of saying 50, you can say 100. And the thickness also, I believe I can increase over here. This still looks small, so I'll do like 200. Yeah, this looks fine to me. So we have drawn a line, which is a progress for us. Right. So we have drawn a line. Now, next, what should we be doing is we need to draw these other lines that we have. Can I zoom out? Okay. So now I have drawn this line, particular line, and my page is gone for some reason. Okay, it's back. I don't know. Now we want to draw these two lines, and we want to do this recursively. So what I'll do is draw left line, draw right line, right. And how you can draw these lines is interesting. So I'm not sure if it is going to be on the left side or not, but I'll try my best over here. So now we want to call the draw branch function. The start for this will be the end now, and end left. End left is something interesting that we would want to calculate. So rl dot vector 2 right, and we will have our end right over here. So this is our end left and this is our end right. Now you want to do the angle sort of a stuff, which is interesting. And how you can do the angle thing is something like this. So you can basically, what I will do is angle a line 2D. Do we have any good drawings? Okay. We have some drawings. But I want the one with like sine and cos, because I want to explain that thing. Yeah, something like this. We want to draw this particular line on the right, and we have this angle called theta. Now what we want to do basically is we want to draw this line. So uh, if you know from mathematics class that if we have this sort of an angle, and can I erase few of the things over here? I need some. Oh, I got it. So if we have a circle in the axis, and this is our angle, let's say theta, then you must know there are like two formulas. One is for sine theta. Okay, drawing with this is almost impossible, and now the application hangs. Great, great software experience. So I'll close this one. I'll try to explain over here. So we have this one. Yeah. So sine theta will basically be the opposite, which is y, and divided by this hypotenuse, which is the radius of the circle. And if we say it is a unit circle, the radius of that circle will be equal to 1. So basically sine theta is equal to y. And if we say cos theta, I hope I'm saying correctly, sine theta formula, we can look up at this thing. So we have this sine theta is the opposite. So opposite is y. So I'm correct. Sine theta is equal to y and cos theta is equal to x. So this is the thing we will be using over here. I'll simply write here for my piece. So sine theta, I'll say q for some reason is equal to not x, it's going to be y, and cos theta is equal to x. Now what we want to do, so we have our angle, right? And what we basically want to do is shift it towards the end, left side, right? So we want to change the x and the y coordinate for this one. Let's do for right first, I believe, and then we will come to the left one. So we draw the branch and right, and our thickness will decrease by some parameter. So thickness into 0.75, let's say, and the angle will also change. So one thing that we haven't done is we haven't used the angle till now, but now we are going to use the angle, I believe, right? And for this I will need some sort of mathematics in Odin. How do we do that? How do we do Sine, do we have sine? Okay. Sine Odin program language. Basically it should have a math library, I believe. Do we have a math library? We do have sine theta, mat dot sine. We have mat dot sine, sine cos. Return the sine theta in radians. In radians. Alright, so we can use this function sine, and inside which package do we have this? Core math. Okay, so we do import math as core math, and let's do one thing. Calculate this thing. So x is going to be cos. So math dot cos. Cos. Cos f32, I think. Yeah. Cos f32 underscore, and what we will pass inside this is going to be, okay, we need to add to the particular thing. That particular thing is, you need to add the stuff to the existing end. What I mean by that is, if come back, I need a good drawing application, probably. Maybe I should write one. That can be a cool idea. So let's just start with this one. And so now x will be the existing x, so which will be n dot x plus this thing, and n dot y plus, it's not going to be plus of course, but I think we need a length. So instead of passing the start and the end, what we should do is we should do vector2 over here, something like this. We should be passing the length. Yeah, I just realized we should be passing the length, which makes sense. Which is going to be f32, and what are we going to do? So end will now be equal to vector rl dot vector2, which will be here rl dot vector2. Our end will now be calculated using that particular angle, so it's pretty cool. Yeah. So x will stay the same, I believe. So x stays is equal to your start of x. Okay, so it's basically start dot x plus your length into whatever you have. So length into, so x was cos of f32. What does vector2 have? If I go back over here, vector2, I want to see the definition of vector2. Okay, vector2 is f32, which is good. Right, and yeah, cos of the angle, I believe it should be something like this, and end dot y is going to be plus length, not plus, and should be minus. We need to keep that in our mind. And I think we need not do this thing over here. So length into sine f32 of the angle. Do we have something incoming? I don't think so. Okay. This is what we have for end. Let's just comment these lines for now, and first we want to draw the line that we had using these angles, and we want to change this thing. So now we don't have an end position, we have a length. We don't need this. Length, I'll say 100. Let's see, what do we get? Okay, so this cos and sine function are math dot, and this is also math dot. End dot y, name end y. Okay, this is going to be start dot y. Yes, we got the line. So we drew the line, and I think we can increase the length like 200 maybe. Yeah, this is good. This is good. And thickness also, I think we can make something like 15. Yeah, this looks good to me. Now what we want to do, we want to angle things on left and right. Let's do right side first. And right, we need not to calculate. We will pass a length is going to be, I would say 0.8 maybe. And we have the thickness, we have the thickness as well, we have the angle. So angle is something now we want to change, I believe, right? Do we want to change the angle? Of course we want to change the angle, otherwise let's just not change the angle and see this. This will go into like infinite loop. It gives segmentation fault. Okay, I don't want. Yeah. How I can do this one? So I can say iterations, or I can go till my length is 10. If length is less than length is less than 10, then we just return. Yeah, so you can see the angle never changes and it keeps on drawing basically. So you want to change the angle, you want to change it to the right, so that means it should be what do you want to change the angle to? Okay, initial angle is 90. Let's do something like 30. But I believe this is not going to be correct. And what is it? Degree to random. See, we got all the things going right. And then it goes right, 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 right. But we want it go something like this. So we have to do something with the existing angle. We can say angle minus. Now let's see. Ooh, this is good. So we have angle of here, 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 and we draw this fractal tree. This is cool. So this is the right side. We do the existing angle that we have, which is 90, and then we subtract something from this. So it goes that side. Right. What else can we do? So 90, and then you subtract something, subtract. Right. Let's draw the right line as well. So instead of you subtracting, you will be adding. Ooh, look at this. We have the tree. We have the fractal tree, but I believe I have the length is too much, so I'll change length back to 100. Oh, so this is the fractal tree that we have finally drawn, and it looks pretty amazing to me. The branch thickness kind of looks the same, so what I'll do is I'll tune the parameter of thickness. I'll say uh, thickness delta to be something like 0.5, and instead of using this I'll use thickness delta, and I'll use thickness delta. Okay, it's too less of a thickness. No. 0 0.6, 0.7. Yeah, this looks good to me. So this is the fractal tree we can draw. There are like interesting things you can do out of this code. Uh, you can change this angle to something random. I'm not sure where is the random thing. So you go here, math.random, math underscore big has a random. Okay, integer random. You can do a couple of things from this one. Yeah, you can do one like pretty simple and interesting sort of a thing. uh you can change the angle for both of these. You can say one angle I'll keep 20 and another I'll keep 30, so your tree will like skew a little bit, which is pretty interesting in my opinion, right? And if you so it's fun playing with this thing, and you do 10, it will skew more. So yeah, now your tree is skewed. This is pretty interesting stuff. Do we have anyone? Let's see. Okay. um, yeah, so this was basically it for this stream of this video. If you are watching it later on, I'll do one thing. I'll attach the, what do you say, the fractal tree Wikipedia in here. So this is my, this is not my, but this is like fractal canopy. This link I'll attach it in the description. And thanks a lot for watching. Thanks a lot. I'll see you in the next one. Bye bye.